WhatsApp number. Just reach me, feel free, reach me directly, and let's get to the real business. This is the Brainiac Academy, where ordinary students develop extraordinary results. So if you are preparing for exams, 2027 exams, specifically JAMB, this things will learn from atomic structure. Alright, now, so where should we start from? Atomic structure, it's actually, coming from, the word atoms. You know what atoms are now? Like, smallest indivisible particle of an element that can take part in any chemical reaction. But that was Dalton's, theory. But we found out that this Dalton's theory is not correct about this atomic structure, because atomic structure is actually subdivided into our pen: proton, electron, and neutron. My PEN, pen, proton, neutron, and electron, in which my proton is a positively charged, this one is negatively charged, while this one is what? Neutral. Shall you get? Neutral. So as you can see, it's actually divisible. So why would you now tell me that atoms are indivisible? So Dalton's model of the atom is not correct. Are you with me? Dalton's model of the atom is not correct, is not acceptable. But then this atomic structure, like the idea of this atomic structure, blah blah blah, was coined by, crafted, starting from our Greek philosophers. Please take notes. Greek philosophers, you have to pay attention to details, and that's what we do in Brainiacs. We pay attention to details. So now, what's the details about this Greek philosopher? Actually, these people are from Greece, and this is their language actually. Are you with me? Now, we'll actually see that these philosophers means like they are thinkers. They are people that reason. Like, now let's break this word down. Philosophers. Let's see who these people are. Now, we have the word from these philosophers. It's coming from the Greek word philo and Sophia. My philo, and I believe Sophia, you're watching me. Sophia, yeah, you're watching me. Go and carry the book. So this is your name here, and your name means wisdom. You get Sophizo. Alright, let's call it Sophia first. Then Sophia. Now, philo here means what? Love. Please follow me. We are going somewhere. Atomic structure would make sense to you today. So, philo, yeah, means love. Then the Sophia now means your, wisdom. You get wisdom. Then, so now you can say that philosophy would mean the love of wisdom. Now, who would a philosopher now be? A philosopher will not be the lover of wisdom. Can you decode that? So that must be noted. Just note that down. Just like a very few one. Now, let's move. So they actually brought, the idea of the atom, blah blah blah. Then now, there are still some of my guys that actually brought about, this atomic structure, its modeling and all. So we have that of, many of them. We have that of we have J.J. Thomson. We have J.J. Thomson. We have, our, who again? Who do we have? We have many of them, and most of these people, when I was in 100 level, then they were in 200 level. So they are guys, actually. So we have our Roberts, Millikan. We have many of them. Millikan. We have our Ernest, my dear brother Ernest Rutherford. Are you with me? I hope you guys can see what I'm writing very well. Then we have James. James is a good brother actually. James Chadwick. James Chadwick. Then we have Henry Mosley. Are you with me? Henry Mosley. We have many of them. We have Michael Davy. Let me just write Michael Davy here because this Michael Davy here. Michael and Davy. And Davy. I hope you guys are getting me. I hope you guys are not confused already. So we have many of them actually. We have many of them. We have the De Broglie. We have De Broglie. We have Yesenbach. You know, we have Yesenbach. We have yeah, many of them. So let's just look at the most important ones. So we look at the most important ones, and then yeah. All right, let's go. This J.J. Thomson. Let's start. Okay, Michael and David first. You see, Michael and David, they're actually the one that like brought about Michael Faraday. Yeah, Michael Faraday. That's your MF, Michael Faraday. Sha. So and David, Humphrey David. So the two of them, they actually brought them. They open our understanding to like to get that that the atoms are what electrical in nature. Like atoms are what electrical in nature, and they may be subdivided into proton, neutron, and electron. So that's their work. From Michael Faraday now, our inventor of electricity. So he was telling us that atoms, you know, are electrical in nature. So that's what he did. Him and Davy, they work together. Now, coming to J.J. Thomson, you know, J.J. Thomson is my guy, and the experiment he did was just like, you know, this what's the name of his experiment again? No, this my guy. How will I forget? J.J. Thomson. What do you do? Tell me now. That's discharge. The discharge tube experiment. So this is what J.J. Thomson did. And how does a discharge tube experiment look like? Maybe something when you have this will be your source. Then this source is coming where you would have your cathode and anode and gas. So there will be an opening here. There will be an opening. This one will be connected to the lamp. Then here will be your cathode. Here will be your anode. So your anode is what? Plus. Cathode is what? Minus. Then you have your gas moving in and out like this. Then that's that. So this is the, you know, discharge tube. So now J.J. Thomson actually passed a potential difference across this discharge tube. Then he noticed a glow. Don't let us go into that story. You don't need all those stories, but you need the key things you will be needing is what me I will be showing you here. Now, J.J. Thomson actually, you know, the name of his experiment is actually the discharge tube experiment. Are you with me? Now, what this guy did, what this my guy did was that, you know, he observed the glow in this discharge tube experiment, and he now told us that okay, this glow is now as a result of rays now bringing us to what? Our cathode ray. So he did the cathode ray experiment. So when you say when you hear about when they say, you know, cathode ray, they are actually talking about, you know, this guy's work, cathode ray, J.J. Thomson. And this guy here now, like he showed us this cathode ray properties, where he said that, you know, like he said they would travel on a straight line. You must note that they would, cathode ray properties, like number one, they would travel on a straight line. And then the second property is actually coming from what this guy discovered. This guy here which happens to be my guy, was the one that actually discovered the electron. Please take note. Electron E. And electron E is negatively charged. Electron E is negatively charged. Are you with me? Electron E is negatively charged. That means that, you know that they said minus would attract plus and it will repel itself. Are you with me? Since it's minus, that means it's actually going to go and attract the opposite charge. You get? So the number two properties of cathode ray is that they would attract positive charge and repel, you get, and repel negative charge, since the charge they are carrying is negative. Sure, you get? Now, they have a constant value, and this value is actually coming from what this same guy discovered, because he actually was able to calculate the charge to mass. That's the E over M. The charge Q of E over M. Now, you have to now know the value. You have to know the value of your Q of your charge of electron. What's your charge of electron? You should know these things. These values are values you should know. And this value is that's what we do for our charge to mass. And we found out that it's J.J. Thomson that discovered this charge to mass. Are you with me? Now, what's your charge? The charge of an electron is given as 1.6 exponential minus 19 coulombs. Now, divided by what's your mass of an electron? The mass of an electron is given as your 9.1 exponential what? Minus 31 in kilogram. Press your calculator. Let's get the value of our charge to mass. So now, press your calculator, which is 1.6 exponential minus 19, alright, divided by 9.1 exponential minus 31. That's 1.75 approximated to what? Where would I write it like this? Let me just manage this, please. 1.76 exponential 11. That's your coulomb per kilogram. You can see now the units will come together. Coulomb per kilogram. As simple. So this is our constant value for what? For our electron. And this is what J.J. Thomson discovered. So this thing led J.J. Thomson to the discovery of electron. Don't forget where we were coming from. Michael Faraday and Davy discovered that atom is electrical in what? In nature. Why? Your what? Your J.J. Thomson discovered the electron. He even calculated the charge to mass of the electron. See, follow closely. JAMB is in trouble. Yeah, JAMB is in trouble because you know me. Now, continue. So I think should we stop there? I think these are things you need to know. Charge to mass. They discovered the electron. That's J.J. Thomson. Now I think we should move like a flash. Robert Millikan. You see this guy here? Let's clean the board first. Let's clean this board first. We need to clean the board so we can. Now let's move, and we just did for J.J. Thomson, right? And guys, please, you have to take note of some certain things under this cathode ray experiments that J.J. Thomson actually did. You have to know that this rays travels on a straight line. Are you with me? Then you should know your constant value, which is actually coming from your charge to the mass. I've said this before and I've calculated this before. I just calculated this now. And the value is what? 1.76 exponential what? 11. Alright, and you should know that when you cast, how will I call it now? If you place an object in their parts, they will cast shadow on it. It's not hard. This is it. When you have let's say this my marker is a torchlight, and I point this marker to this board. What would happen to this board? You will see the shadow of the reflection of light on this board. Sure you get. So cathode ray too, when you place an object inside it, you will see a shadow, like a shadow of something, of that not of something, say of that object, of that particular object inside it. So they would like, I'm not just explain it to them, they would like cast the shadow of it. You get? So let's talk professionally. More in let's say they cast the shadow of an object that is placed in, you know, their path. All right. So I think those are things you need to know. And then when you put a paddle wheel inside this cathode ray, it will set it into motion. Yeah. So let's just move. Okay, Robert Millikan. I think let's do for Robert M.A. Robert Millikan. So this one, what he did was, he did for oil drop. So the name of his own experiment. You know, the one of J. Thompson is what? The discharge tube experiment, leading us to our cathode ray, and we talked about the cathode ray properties. Now, Robert Millikan did for, you know, oil drop what? Experiment. You get? And in this oil drop experiment, he calculated the charge of an electron. He was able to calculate don't forget where we are coming from. J. Thompson calculate the charge on mass, QE over ME. No, but this one is actually calculating the charge on an electron. Now, and you know the charge. Now, I mentioned this charge there, where we have 1.6 exponential minus 19 what in what coulomb. That's our unit for charge. So, as you can see, this one is the charge, and this is what he calculated in his what experiment. We don't need to do anything much here. That is all experiment. Oil drop experiment of Robert M.A. Millikan, oil drop. So your Millikan jerrycan, oil drop experiment. So this is the charge, and we can use this charge in the formula to calculate for Thomson. This is charge to mass. So this is where we get our formula from. So Robert M.A. Millikan determine what? The charge on, you know, your electron, which is 1.60 exponential minus 19. So now combining this value here, dividing into the value of mass, would obtain what? What? You should know it now. Yeah. Your charge to mass now. Sure you get. So now the second guy, when I was in 200 level, then it was in 300 level. So these people are my guys. They are my paddies. We have the Ernest. This is my markers. Why will my marker not write, for God's sake? Oh, let me change it. What's going on? You guys need to buy marker. Premium students, you need to do what? You need to buy marker. Help my life too. So like that's Ernest. How do they write Ernest? Bye. Ernest, my guy. Ernest, my beautiful guy. Ernest what? Rutherford. So that's him. And then this Ernest Rutherford, what did he do? What did Ernest do? Now, his own experiment is not oil drop. His own experiment is the AU foil. That's the gold foil experiment. Gold foil experiment. This is symbol for gold. So you see, as you can see, that's for gold. If you want to write your mercury, that's your Hg. Sure you get now Hg. So if you want to write for your silver, that would be Ag. But gold here is what? Au. So, and the name of his own experiment is our gold foil experiment. And this experiment is not hard. Don't see it as something that is hard. Picture something like a foil. Let's call this a foil here now. Let's call it a foil. Let's call it a foil. And this foil, actually, you know, something I want to pass through it. You know, picture a table tennis. A table tennis, where you, like, okay, let's use the ball, the tennis ball. When you throw this tennis ball to the wall, what will happen? The ball will reach the wall. And when it reaches the wall, it will bounce back. So the ball is actually going to back. Now, we, instead of using the ball, we will now use alpha particles. Alpha what? Alpha particles. We will now bombard it, like we will throw it at this thin gold foil. This is our gold foil. Please don't forget. This is simple. Follow closely. You are cramming before. You don't need to cram. You don't need to cram at all. JAMB 2027 is in trouble because you know me. So gold foil here, we want to bombard it with what? Alpha particles, making this one our tennis thing. So when we throw it, in here, what Rutherford saw, me and Rutherford saw was that this gold foil will pass through this alpha particle will pass through this gold foil. So the second alpha particle is passing through the gold foil. The third alpha particle is passing through the. So we have plenty alpha particles passing through the gold foil. Plenty alpha particles passing through the gold foil. Plenty alpha particles. Now he said most of the alpha particles would pass through the gold foil, while just few would be deflected back. So like if some like they go inside, so all of them will not go inside finish. Just few will deflect, like the table tennis ball bouncing back again, like bouncing back. That's deflecting. So just few will deflect. As you can see, we have 1, 2, 3, 4, 5, 6, 7. Now 7 actually pass through the foil. Why just 2 or 3? Let's just use 2. 2 actually are deflected back. So you can see that most pass through the foil, while few are deflected back, and that is the experiment of Rutherford. That's what we did. Then after that, in a bit to like explain this thing much more better, he now brought about like the nuclear model, where he said that at the center we have the positive this thing like concentrated at the center. We now have a circle, then like a cloud, a small cloud inside. So you now call this part the nucleus. And as you can see, since it's like positively charged and positively concentrated, your proton, that will be your proton. So you get your protons will be there like that. So that will be your nucleus plus proton, your nursery and primary. So now, and this proton, how do we know that proton is there? Because it's positively charged, and our proton is what? Positively charged. And as you can see now, the extra nuclear part, like all these parts, like this large big part that is around it, will now be your electron. So this is what Rutherford was using to like explain this, using the nuclear model. Are you with me? So all right, I think we can move now. I believe we are getting this thing very well. So all right, let's go to another scientist, which is James. You don't even need to prove for James Chadwick. As you can see, James Chadwick was the one that discovered the what? Neutron. Just put it in your head. James what? James Chadwick. James Chadwick discovered the neutron. Put it in your head though. So we are going somewhere. Actually, and this is just the part 1. Part 2 is coming. We are going somewhere. Now, Niels Bohr. Should we go into Niels Bohr now, or we should just call it a session? Then we come back for part 2. There's a calculation of aspects to this all these scientists blah blah blah, which is where you be having your energy levels. That's under Niels Bohr's model that we'll talk about in the next video. And if you would like to, understand this electronic transition, your PAMS, PMS, that principal, azimuthal, magnetic and spin, blah blah blah. I've done the video already. You can just go and look for it and understand, because there's no how you study, Niels Bohr's experiments that you not journey into that calculation. And it's very simple. And just check. I've done the video is there. Check it. You see trouble. All right, that's the part one. Feel free to message me. Feel free. See, feel free to message. That's my number. Feel free, message me. Yeah, register for tutorials. That's TBA. All right. Yeah, what? Ordinary students develop extraordinary results.